Okay, now, this is the equation. Sodium cyanide, I have 0.01 molar, the brackets mean molarity. And I know that sodium cyanide is a sodium salt, group 1. And if I have a positive ion from group 1, what do I know? What can I conclude about the dissociation of salts made from metals from group 1? They are what? They're 100% dissociable, 100% soluble. They completely see, sugar is 100% soluble, but it doesn't dissociate. It stays as one particle. This is going to dissociate completely. So that's what I get. So if I start off with 0.1 molar, 0.01 molar of this, how many moles of this do I get? What's the concentration of the sodium ion? 0.01. And the cyanide?
0.01.
Okay. Now, remember the sodium is a spectator ion, correct?
Yeah.
So what are we looking at? First of all, the problem gives the Kb. What does B stand for? The base, right. So that's the dissociation constant for a base. Do you see a base up here? Do you see, think Brownstedt-Lowry, a hydrogen ion acceptor. I'll give you a hint. Cyanic acid is a weak acid. Cyanic acid is a weak acid. So yes, Cn -1 is going to be a base, right?
Yeah.
Okay, so it's going to be right?
Yeah.
Now, by the way, make sure, please, you're looking at the lecture for this that goes along with this on YouTube, correct? Okay. So this is going to be, I never go down. Here I'm going down, isn't it weird? So this is 0.01 molar, right? What's going to be how do I represent the molarity of these that are formed in solution? Isn't this going to attract a hydrogen ion?
Yeah.
And what's it going to form?
1.
Where's it getting the hydrogen ion form from?
From
From water, right? So what am I forming?
OH.
Right. So what do I represent? What am I looking for? You don't know yet. I didn't tell you that part of the problem. But you're actually looking for the pH of this solution. This is the salt of a weak acid. Remember we did some problems, salt of a weak acid. Why does it become basic? Remember we did that? Okay, you should look at that video if you didn't. So in order to find out the pH, I need to know the hydrogen ion concentration, correct? Yes or no?
Yeah.
Now, but if I know the hydroxide ion concentration, can I determine the hydrogen ion concentration? Can I? Yeah, because I can say 1 times 10 to the negative 14 divided by the hydroxide ion concentration equals the what? Hydrogen ion concentration. So in other words, correct? So if I know this, I can divide through and get this, correct? Correct?
Yeah.
So I can say
1 times 10 negative.
Can I find the hydroxide ion concentration using this formula? Can I? Yes. And what's the Kb expression for this? First of all, I want this. Where X, aren't I looking for X? Aren't I looking for the hydroxide ion concentration? Isn't that what I'm looking for? Isn't it?
Yeah.
And for every one of these I produce, aren't I producing one of these?
Yeah.
Right? Yes or no?
Yes.
Yes, okay. And what do I have to subtract from this? Because for every one of these I make, what do I have to do to this? Haley, you with me? No, you're not, I understand, but you're focused on something else. You weren't, if you didn't have a grade of 140, I would say something, but carry on with it, whatever you're doing. Okay? So what do I have to subtract from that? What am I making? Aren't I making this?
Yeah.
And by default, I'm making this, correct? Right? So if I make this, aren't I getting rid of this?
Subtract.
Isn't that decreasing by how much? How much will that decrease by? The molarity of X, right? Now, I made a video to determine whether or not you need to actually say minus X. Now, unless you've done the reading, you really have no idea what I just said, although you did hear what I just said. So what I just said is still very important, and it will become clearer what I just said, even if you didn't look at the videos, in about 6 or 7 minutes. Yes? Does that make almost no sense?
Yeah.
Okay, but it will make sense. All right. But this is all I want to ask. This is all I want to ask. This is where you should be right now. Okay, you ready? This is where you want to be. Okay. I have 0.01 molar cyanide in solution because this dissociates completely and produces 0.01 molar cyanide. That's all you need to know so far. Check? You get that? Okay. The second thing you want to know is that the cyanide is going to produce hydroxide ion, correct?
Yeah.
Now, we want to find out what the hydroxide ion concentration is. Do you understand that? Do you understand that the reason we want to find out what the hydroxide ion concentration is because ultimately we want to find the pH. Do you understand that?
Yes.
Now, in order to find the pH, we need the hydrogen ion concentration. Yes or no? And the hydrogen ion concentration we can get through this equation. Do you understand that?
Yeah.
Yes or no? Okay, good. Do you understand that the molarity of the hydroxide ion concentration is what we're looking for? That's the unknown, so we're going to make that X, correct?
Yeah.
Now, you see from the equation that the HCN and the OH are produced in equal quantities, correct? So they're going to be given X, yes or no?
Yeah.
So for every X of this I produce, I subtract X from this. Does that make sense?
Yeah.
Okay, therefore now we're ready. Now, you know, because I've done this in class, the Kb expression is going to be the HCN times the OH divided by okay? Did you get that?
Yeah.
It's going to be the product of the products divided by the reactant. Yes?
Yes.
Excellent. Okay, good. Let's plug in.
X squared.
All right? This is X and this is X. What's X times X?
Squared.
X squared. So it's going to be equal to X squared over, what's this value going to be?
0.01.
0.01 minus X. Can we leave off the brackets? We know that it's all molarity, okay? So it's going to be 0.01 minus X, right? And that's going to equal this, correct? All right, now, unlike Wednesday, I want everybody to take out their calculators and follow along with me, okay? Everybody take out your calculators. Okay. So now we have to solve for this. What is this going to reduce to, this expression? Does anybody know offhand? What is it going to reduce to? Starts with a Q.
Cubic.
Oh
You
my.
love this. Cubic starts with a Q. Yeah, all right, I understand. I know. Okay, it's fine. Yeah, exactly. Yeah, I know. That's fine. I'll get over it. A quadratic, right? So do you understand that this is going to be x squared equals?
Isn't there a different way to do this also?
Yes, and that's on a video that I made last class. I'm going to get into that.
That way's harder.
Which way's harder?
This
The
way.
second way.
This way's harder?
No.
The other way's harder?
The quadratic formula.
That's what we're using now, Michael. Have you joined the conversation? Could be because your computer's open with an earbud. So are you listening to the international news or something, CNN, or what are you doing? Okay, Fatima, keep him on task, please. Okay, times 10 to the, right, -5 times 0.01 minus x. Do you understand that that's correct? Yes or no?
Yeah.
Yes or no? Okay, can I erase this? Is that all right? I just need room to work. Yes. What's the problem? Low battery? Okay, let me hook it up to a computer.
That's an error.
I hope I have my, I'm gonna get through this pretty quickly if I don't have, it says low battery, okay?